Okay, so we've got a lorry of mass m, and it's pulling along a trailer of mass 3m, straight horizontal road. We're not told that the surface is smooth, but later on they mention some resistance forces, so that some of those will be due to friction on the road. And we're given the driving force of the lorry and the rate at which they're accelerating. Okay, and the first thing we need to find is the mass of the lorry and hence the mass of the trailer. So that's implying that we'll find the value of m, and then obviously if we've got m, the trailer is 3m. Right, so as always, we're going to start with a sketch of what's going on. So I'm going to have mine moving to the right. Okay, so I've got, so this is my lorry. So that's mass m, and then this is the trailer with a mass of 3m, so they're going to have weights of mg and 3mg. There's a lighting extensible tow bar, so there's tension in that tow bar. So there's tension pulling the trailer along, and then there's tension slowing down the lorry. And then there's a driving force of 50,000, which we've gone off zeros, yep, 50,000 newtons. And then the lorry has a resistive force of 4,000 newtons, and the trailer has a resistive force of 10,000 newtons. Okay, and I need the mass of the lorry. So I'm going to model the entire thing as one single body, because then it means I don't have to worry about tension, because those tensions are going to be equal and opposite. So if I look at the whole thing, so it's everything combined, the only force off to the right is the driving force of the lorry, and then slowing it down, I've got the 10,000 Newton resistive force on the trailer and 4,000 resistive force on the lorry, and I don't need to worry about tension because the two values of tension are equal and opposite, so they're going to be cancelling each other out. So if I use F equals ma, and it's moving to the right, so I'm going to use right as positive, and I'm told that it's accelerating with an acceleration of 5 meters a second squared. So going off to the right, I've got 50,000 newtons, and then minus 4,000 and minus 10,000, and that must equal the total mass. So the total mass is 4m, that's the 3m for the trailer plus m for the lorry, times acceleration, which I'm told is 5. So the only unknown there is m, so I'm going to be able to solve that to find m. So 50,000 minus 10,000 minus 4,000 is 36,000. That sounds right? Yeah, that sounds okay. And that equals 20m. So m is 1,800 kilograms, and then make sure we answer the entire question. So that's the mass of the lorry, and then it did also ask the mass of the trailer, so that's going to be that multiplied by 3. So the trailer is 5,400 kilograms. Okay, right, and then it wants the tension in the tow bar. Right, so that's fine. To find the tension in the tow bar, I'm just going to look at either the trailer or the lorry. It doesn't matter which one. So let's look at the trailer. So there's the trailer. It's being pulled along by the tension. I know that the resistive force on the trailer was 10,000 newtons. The mass of the trailer we already worked out was 5,400 kilograms, so the weight of the trailer is 5,400 g, and there is a reaction force. And I know that it's moving with acceleration 5 meters a second squared. So Using F equals ma on the trailer and taking right as positive, T minus 10,000 newtons is its mass of 5,400 kilograms times the acceleration of 5. So T is going to be 5,400 times 5 plus 10,000, so 37,000 newtons. Okay, and then part C, we'll just look at the solution for C. So explain how the modelling assumptions at the tow bar is light and inextensible affect your calculations. Well, if you answered question 1, you answered exactly the same question. So the fact that it's inextensible means that it's not stretching, so acceleration of the lorry and the trailer will be the same, which obviously we assumed because we used 5 meters a second squared throughout the question. And it's light means that the tension will be the same throughout, and also that we don't need to worry about the actual mass of the tow bar. That's just in relation to the masses of the trailer and the lorry, it's just insignificant. Okay, so again, that's a really common, I mean, that's always going to be the case whenever you've got any kind of tow bar, any rope, anything like that. They will always be light and extensible. So if they ask you the assumptions, you can just memorize that answer.